All right, so this is Stephanie Washer, and we're going to go into IPv4 addresses 3-2A of the Cengage MindTap Network Plus Guide to Networks. So this is for the RBC class, Network Essentials. And IPv4 addresses are very important. We didn't really talk, we did a very basic overview. And so IPv4 addresses are 32-bit addresses. And the format of that is, we call it octets. So there's 4 octets. And each octet can have a number 0 to 255. And we can have, we can have quite a bit of numbers. So in here, we've got 4.3 billion IPv4 addresses that we can have. But some of the IPv4 addresses are reserved, so we might not be able to use all of that, right? An example that I've been using is 192.168.1.10 or 1.20. So we've got 4 groups, 8 bits each. If we were to put all ones, if it was all ones, so the largest one would be, we've got 8 ones plus 8 ones plus 8 ones plus 8 ones. So, and we separate it by a decimal. And the largest number, the smallest number you can have in each octet is 0. The largest number you can have in each octet is 255, which makes it easy for binary to decimal conversion. It makes it a little bit easier for us. So the first part of the IP address identifies the network, and the last part identifies the host. And so in the past, we used to have class full addressing, where we had an automatic class assigned to whatever the first octet, corresponding to that number. So if that first octet was started with a 1, anywhere from 1 to 126, that one had a default subnet mask of 255.0.0.0. So that's why, when you go in and you change your IP address, and set it statically, it might automatically pop up with one of these default subnet mask numbers. So if it's class B, it's in that first octet. If we start with 128 all the way up to 191.255, you'll see that it'll automatically go 255.255.0.0. If you have class C and it starts with a 192 to 223, 255, then your subnet mask is going to automatically be 255.255.255.0. And so usually I just look, and I know they add these other parts in, but I usually just look at that first octet. So I know 128 to 191, that's going to be the class B default. 192 to 233, that'll be the class C default. And because of the class full, we can say the number of networks possible is 126 for class A. But we have a ton of hosts. We have 16 million hosts we can have for each network. So this is for larger networks. And then class B, 16,000 networks possible with 65,000 hosts. And then with class C, we have 2 million networks possible with 254 hosts per network. So in the class A, B, and C, that's what we use for the IP addressing. Class D and E, they're multicast and reserved, so we don't really worry about them too much. But if you want to know those numbers, class D is 224 to 239, and that's multicast stuff, transmissions, messages. Class E is 240 through 254, and that's research. So those are some things. And the Network Plus exam expects you to identify the class. So they expect you to know. So when you take the Network Plus exam, you need to know which one is which. So they're saying right here, this 3-1 is a good table, and I agree, it is a good table. And we have many, many different numbers that we can go through. So if we look at that, if we remember from the table, and class A had octet 1 was a network address, and then the last 3 octets were hosts. So this is just kind of a different way to look at it, where the first octet is your network and the last 3 are host. Or with class B, the first 2 octets are network and the last 2 are host. Or with class C, we've got the first 3 octets are network and the last one is host. So, these are just a different way of looking at that. And class A, we also have what's called the public versus private IP addresses. And that is another thing that you need to memorize for that exam. So public IP addresses, it's also something good to know when you're going through and looking at traffic on your network. So you want to be able to identify which traffic is internal, private IP addressing, and which one is external, public IP addressing. So you can go through and you can see you've got public IP addresses. So Class A has their own private IP address, Class B has their own private, and Class C has their own private well. Anything other than these numbers would be a public IP address, other than the 127. So we've got Class A is 10.0.0.0 through 10.255.255.255. So that's the private. So really what I look at for, if I see anything that starts with a 10, I know that's private. And then if I see it starts with 172, then I look a little further to make sure. And with Class B, it's 172.16.0.0 through 172.31.255.255. And with Class C, again, if it's 192.168, I know it's going to be private. So 192.168.0.0 through 192.168.255.255. So generally, and you can tell my IP address on my computer was 192.168. In the previous example, 1.20, I believe it was. And that is a private IP address, but the router will give it a public IP address so that it can communicate on the network. And so laptops, desktops, smartphones, they might have a private IP, but there is what's called network address translation so that it can get a public IP address to represent it on the internet. So private IP addresses aren't going to be routable on the network. So it won't go past that gateway. There's got to be a network address translation for IPv4, network address translation so I can go across the network. Here's reserved IP addresses. If it's all 255s, that's a broadcast message. So if you are using, so there's different tools we can use like Wireshark or different packet sniffing software, and you can look at the IP addresses, and if you see this going across the network, that's a broadcast message. Routers don't forward these broadcast messages, so it creates a nice little boundary line for that. And then the router is what breaks up a broadcast domain. So switches break up collision domains, but routers break up broadcast domains. And so a broadcast, this is sent to everybody on the network and everybody reads it. So you don't want like too many, you want to break up your broadcast domain so that you don't have too many of these messages flying around. 000 is currently unassigned. Here's the other one, the 127.0.0.1 through 127.255.255.254. We use that for the loopback address. If you ping 127.0.0.1, you're pinging your loopback, you're just testing your network stack to verify that everything is working correctly on your computer. If it starts with 169, double check, make sure it's the automatic private IP addressing. I call it a PIPA. And that is when you can't get your DHCP connection to work. So you're not getting an IPv4 address from the DHCP server. So anything that starts with 169.254, you are going to be like, ah. And so you just want to double check your connection to make sure that you're connected to the network or not. Sometimes it's as simple as you just aren't plugged in. So in the past, we had the class full addressing. Really, now we just use classless addressing, and we can divide all of the networks up, and we can use what's called the CIDR, the classless interdomain routing, or the slash. And so we can just use that to show us the dividing line. And so we can subnet those networks into networks that we need. So if you have a class A that has a ton of different hosts, so we can break that up into different subnets, and we can set everybody on their own little network. Well, not every single person on their own network, but we can set up our network however we feel fit. Most of the time when you're going into an organization, they're going to have it already set up. And so you're going to know, like via spreadsheet or however they do their documentation, whatever they're using at the time, then you'll know exactly how they're doling out numbers, how they're setting up subnets, how everything's working. So you'll know all that. So CIDR interdomain routing is slash notation. So instead of 255.255.255.0, you're going to have /24. So My computer was 192.168.1.20, so it would be 192.168.1.20/24. So that /24 is just the number of bits or the number of ones from left to right. So we've got 24 ones, and that would be the first 3 octets, because we've got 8 ones plus 8 ones plus 8 ones, and then the rest are zeros because there's 32 bits total, and that would be a /24. And so the first 3 parts, so this 192.168.89 would be the network. Those first 3 octets, if I could get it to highlight what I want, the first 3 octets would be the network portion, and the last octet would be the host portion. So if we talk about DHCP, or Dynamic Host Configuration Protocol, so we can set it statically, but really most of the time you're going to see DHCP in action. And so you can configure a DHCP server. I've set up countless DHCP servers. I've been setting up servers since we had, Windows Server, NT. I've been setting them up for so long. And then now on routers, it's really easy to set up a DHCP server. And so what you do is you'll set a range. So you can set an IP address pool. And so you've set up a scope. So if you set up a pool of IP addresses to dole out, that is your scope. So DHCP scope and DHCP pool are the same thing. And so here's just kind of like, here's our wireless router that we have. Here's our pool. We can set our lease time. This is in minutes. And then we've got our default gateway, our primary DNS, and secondary DNS. So sometimes these are already, it'll already determine this. So we can have it, just type it in ourselves if we want. And you can notice here it's optional. Mine automatically detected the primary DNS and the secondary DNS. So when you use this, we're starting with 192.168.2.100, and then we're going to go all the way to 199 for our address pool. And again, we can set our lease time however, restrictive we want it. A day is usually pretty good. 24 hours is usually pretty good. But notice here we can go from, we can do in minutes. So the default value is 120. So it automatically sets it to 120. So if you don't change it, that one has a default value. Our IPN. And then we can set other things. So you can actually reserve MAC address. So you can have a MAC address reservation, IP address reservation. You can set DHCP reservations. I have a printer here, and that one I can set statically if I want, and then I can reserve that IP address so that it's not given out. So I can just say that IP address is reserved and it's being used by whatever. So it's not exactly the same thing as static IP because you still have to set it on the machine itself. So you can set the exclusion but you still have to set the static IP on the machine. In Linux systems, you can set DHCP through a text editor. So you can set it up and you edit the configuration file. But also in Linux systems, there are some Linux systems that you can do it through the GUI as well. So we've got different options for that. And you can set your range of IP addresses in that. And you can see here's the subnet declaration, and we've got our range here. And knowing command line in Linux, that is a great skill to have as well. Address translation, I talked about network address translation before. My router, here's kind of the symbol. We've got the gateway, and we need to hit the web server. So our internal network needs to hit the web server. So all of these computers are going to do port address translation. It's a form of NAT. So we're going to do port address translation. The gateway is going to do that for us, and it will sign. We've got an IP address with a port number, which we haven't talked about port numbers yet, but we've got port numbers, and then it'll give us an outside address or a public IP address with a port number so that we can hit the external web server or the internet or whatever. And so network address translation, that's just a single public IP address for the entire network. And so it's just another kind of security measure, and it's going to hide that private network behind the public, behind the gateway, I mean. And the other thing we can do is we can do port address translation. So you can have many different, if you only have one IP address, one public IP address, you can use the ports to communicate across the network, and you can just use that one IP address with the port, and it's called the socket. So when the IP address with that port number together with a colon in between, that is called a socket, and then that we can actually send and receive more information that way using port address translation. I can go into so many different varieties of this, but we'll just keep it short. And so we have source network address translation, we have destination network address translation. So there's a couple different things. So these two variations just to know and be familiar with. So the gateway assigns the same public IP address to the host each time. So source network address translation, same IP address, same public IP address to the host every time. So small networks use this. And then we've got destination network address translation. So the host outside the network address, a computer. So anyway, so the host outside the network address, and if there's a computer inside the network that is trying to get to a web server or email server by a set predefined public IP address, so when that public IP address reaches the router, the destination is changed to the private of the host inside the network. So we've got this destination network address translation, so it's gonna set that up. And so they've got an example of using SNAT and DNAT for outgoing and incoming messages. So we can see we've got our private network going to the outside world, and it's going to use that single or that source network address translation for that. And then when anything comes in and it's got a public IP address, it's going to use that destination network. And so it's just like the source coming from the inside is the source. Anything coming from the outside is going to be the destination network address translation. So that's kind of the easy way to look at those, source versus destination. If you want to configure an address translation using NAT, so you can set that up, and there's many different ways to do it. We have classes at Rock Valley College that I think it's Cisco 2 or Cisco 3 where we go through and we set up network address translation, and we do it through the router. We do port address translation, and we do a simple network address translation first to learn the commands, and then we go through the port address translation. And so here's configuring address translation using NAT, and so they kind of go through it, and there's certain commands that you have to set up. And so this is exactly what the Cisco router, these are all the Cisco router commands, and this is a more complicated class. And actually this is the translation entry table in Linux, but these are the commands we use in Cisco as well. So I just thought I'd point that out. And you can look here and you can see these connections. We can see that 000, it has an IP address of this number and with the subnet mask. So that's what the IP address and subnet mask are. And we can say, so we've got these, and we've got 000, where that is the outside network NAT address. And, oh, okay, so I made it bigger. So we've got the outside, and then Ethernet 1 is the inside. So this is the internal address, and that is the external. And then we've got to set the mapping. So we're just going to say this is going to be a static. So we're setting this manually. So we've got IPNAT, and we've got the inside source. We're statically setting it from our 192.168.10.7 to our external of 6.9. So we're actually, we're setting this IP address, that's an internal IP address, to go and be this outside of the network. So that's all we're doing. All right. In the next video, we'll go through IPv6 addressing. We did a lot with IPv4 addressing this time around, but the next video will be IPv6.